The air here is thin and sharp, tasting of ancient frost and the dust of crushed stone, a cold so absolute that it feels less like temperature and more like a heavy, silent presence pressing against your skin. Imagine you are standing on a vast, open plain under a sky that seems too high, too empty, stretched tight over a world that has forgotten the warmth of the sun. The light is dim, a bruised violet twilight that lingers on the horizon, neither fully day nor fully night, casting long, wavering shadows across the drifts of snow that roll away into forever. If you listen, really listen, beneath the whistle of the wind through the dry, stiff grass, you can hear the deep groaning settle of the earth itself, the sound of ice shifting miles away, a sound like a great door closing in the dark. There is a smell here too, crisp and metallic, the scent of a world held in suspension, like the air inside a sealed room that has not been opened in 1,000 lifetimes. We are drifting now, moving like a shadow across the face of the deep past, not to judge it or to measure it, but simply to witness the way the world breathes when it thinks no one is watching. We imagine this change happened suddenly, that the ice descended in a single terrible storm, a curtain falling on a stage. But the truth is slower, quieter, and far more unsettling, for the cold did not invade. It grew, inch by inch, silence by silence, until it was the only reality the earth knew. Before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know your city and local time in the comments so we can see where everyone is listening from. This is not a chaotic world, though it seems wild to our eyes. It is a world of strict, almost mechanical order, a planet that has fallen into a deep hypnotic rhythm, a heartbeat so slow that a single pulse takes longer than the entire history of human civilization. For nearly 1 million years, this was the rule, the law that governed the Northern Hemisphere, a law written not in stone, but in ice. It was a cycle as reliable as the rising of the moon, a pattern that repeated over and over again, indifferent to the creatures that lived and died within its grip. We call them the Ice Ages, but to the Earth, they were simply the long, quiet exhale of a sleeping giant. The rhythm was simple, though its scale is hard to hold in the mind. For roughly 90,000 years, the ice would grow, creeping southward, burying mountains, drinking the oceans, turning forests into tundra and tundra into polar desert, a slow accumulation of cold that seemed as if it would never stop. And then, for a brief feverish window of perhaps 10,000 years, the fever would break, the ice would retreat, the waters would rise, and life would scramble to reclaim the land, only for the clock to reset, the pendulum to swing back, and the long winter to begin again. It happened 8 times in a row, a cycle so perfect, so mathematically precise, that if you were a celestial observer watching from the quiet of space, you might think the Earth was a machine, ticking through its phases with cold iron certainty. Down here, on the surface, it does not feel like a machine. It feels like an eternity. The cold is a physical weight. You can feel it settling in the marrow of your bones, a reminder that warmth is a temporary gift, a fragile exception to the rule of the universe. The landscape around us is painted in shades of blue and gray and white, a monochromatic dream where the only color comes from the faint greenish glow of the aurora dancing high above, a ghostly fire that offers no heat. The wind picks up now, lifting a veil of powdery snow that hisses across the hard-packed ground, erasing footprints as soon as they are made. It is a world without ego. The massive woolly mammoths, moving like hairy mountains in the middle distance, do not know they are part of a cycle. They only know the grass is hidden beneath the snow, and they must keep moving, keep walking against the wind, their breath steaming in the twilight. They are small, even in their hugeness, against the scale of the ice sheet that looms to the north, a wall of white stretching up into the clouds, taller than any cathedral we will ever build, a monument to the power of water when it stops flowing. Scientists have spent decades trying to read the diary of this frozen world, drilling miles deep into the ice to pull up cylinders of trapped air, ancient bubbles that hold the breath of the past. They look for patterns, for reasons, for the hidden gears that turn the world. And for a long time, the pattern held. It was the 100,000-year heartbeat. Every 100 millennia, the world reset. It was a comfort, in a way, to know that the planet had a schedule, that however harsh the winter, it was part of a larger, balanced equation. But there is a strangeness in the air tonight, a tension that wasn't here before. We are standing at a point in time where the rhythm feels steady, where the rule seems unbreakable, where the future should look exactly like the past. The ice is thick. The oceans are low, exposing land bridges that vanished long ago, pathways of dry earth connecting continents that are now separated by seas. It feels permanent. It feels as though this is simply how the earth is, how it was meant to be. A white planet reflecting the pale sun, locked in a cold embrace that protects it from the chaos of change. Yet, there is a whisper in the data, a ghost in the machine. We are taught to trust patterns, to believe that what has happened before will happen again, that the sun will rise, the tides will turn, and the seasons will follow one another in their appointed order. But deep time teaches a different lesson, that rules are only rules until they are broken. We are lulled by the consistency of the last 800,000 years, seduced by the idea of a stable, predictable planet. We think we know what comes next. We think the ice is inevitable, that it is waiting just over the horizon to reclaim the cities and the fields we have built in the brief warmth of the interglacial pause. But look closely at the horizon. The light is changing. The wind carries a scent that shouldn't be here, a hint of warmth, a trace of something shifting deep in the mechanics of the world. The heartbeat is skipping. The predictable pulse of the ice is faltering, stumbling over a variable it has never encountered before. We are not just observers of this cycle anymore. We are living in the silence after the beat should have dropped. The long winter that should be gathering its strength, preparing to descend once more, is hesitating. And in that hesitation, in that pause between the tick and the tock of the geological clock, lies a mystery deeper than the ice itself. What happens when a planet forgets its own rhythm? What happens when the gears that have turned for nearly 1,000,000 years suddenly grind to a halt? We stand here in the twilight, wrapping our coats tighter against a cold that feels eternal, unaware that we are witnessing the end of an era. The ice sheets look invincible, solid continents of frozen water that surely nothing could move, yet they are more fragile than they appear, balanced on a knife edge of temperature and sunlight and invisible gases. The rule of 800,000 years is about to meet its exception. But for now, the wind just blows, whistling through the dry grass, carrying the lonely call of a wolf across the tundra, a sound that rises and falls like a question asked to a sky that has stopped answering. The stars wheel overhead, indifferent and bright, marking the passage of time in their own slow language, while down here, the earth holds its breath, waiting for a winter that may never come again. To understand the rule that governed the earth for so long, we must look at the ruler itself, the physical sovereign that claimed the northern world and held it in a grip so tight it bent the crust of the planet. We leave the tundra now, that borderland of dry grass and wind-scoured stone, and drift northward, rising into the air, moving toward the source of the cold. The horizon ahead ceases to be a line where earth meets sky and becomes a blurring rising wall of white that swallows the stars. This is the empire of the white, is the empire of... It is difficult for the modern mind to truly comprehend the scale of the great ice sheets that define the last 800,000 years. We have no living comparison, nothing in our warm and fluid world that matches their silent immensity. We tend to picture them as merely deep snow, perhaps a particularly heavy winter that never melted. But they were not snow. They were rock. They were water transformed by pressure and time into a mineral harder than concrete, a monolithic slab that did not just sit upon the land but crushed it. Imagine standing in the location of what is now Chicago or Berlin or Montreal. In our time, these are places of noise, steel, and rushing traffic, but in the time of the rule, they were the floor of a frozen ocean. Above your head, there would be no sky, only ice, a ceiling of blue-gray crystal rising 1 mile, perhaps 2 miles, straight up into the atmosphere. The weight of it is beyond calculation. If you were to stand on the surface of this ice sheet, high in the thin, piercing air, you would be standing on the highest plateau on Earth, a flat, endless expanse of white that curved away with the shape of the planet, higher than the peaks of the Alps, higher than the clouds that tried to cross it. It was a world entirely of its own making, a continent of cold that created its own weather, its own wind, its own reality. The sun here was a blinding, indifferent eye, its light reflecting off the surface with such intensity that to look at it was to be struck blind, yet the heat bounced away, sent back into space, leaving the air shimmering but freezing. It is a landscape of absolute purity and absolute desolation. There is no smell here but the scent of ozone and crushed crystals. There is no sound but the wind, which does not blow so much as fall. Heavy, cold air, denser than the atmosphere around it, sliding off the top of the ice dome and rushing toward the edges of the world, creating the katabatic winds that scoured the lands below. It is a silence so profound it feels loud, a silence that rings in the ears. But the ice is not dead. That is the great deception of the cryosphere. It looks static, a portrait of stillness frozen in time, but it is alive with motion, flowing like a river of glass in ultra-slow motion. Deep beneath us, under miles of pressure, the ice crystals align and slide past one another, lubricated by the immense weight and the faint heat of the Earth's core radiating from below. The entire sheet is moving, spreading outward under its own heaviness, a slow-motion explosion of water seeking the sea. If you lay your ear against the surface, you might hear it, not the whistle of the wind, but a deep, resonant boom, a crack like a cannon shot firing inside the earth, vibrating through the soles of your feet. It is the sound of the ice fracturing, of a crevasse opening up miles away, a sudden jagged tear in the perfection of the white plain. These crevasses are blue scars plunging down into darkness, the only color in a world of grayscale, glowing with a sapphire light that seems to come from within the ice itself. Historians and geologists sometimes struggle to convey the sheer duration of this dominance. We say the Ice Age, and it sounds like an event, a season, a passing storm. But this empire lasted for tens of thousands of years at a stretch. Generations of animals lived and died, species evolved and vanished, stars shifted their positions in the sky, and still the ice remained. It was the permanent state of the world. For a human living on the edge of this expanse, the wall of ice to the north wasn't a temporary weather phenomenon. It was a geographical fact, as eternal and immovable as the ocean or the mountains. They could not know that the ground they walked on was actually sinking. This is one of the stranger truths of the deep past. The ice was so heavy that it physically pushed the continents down into the mantle. The Earth's crust is not solid rock in the way we think of it. It is a floating raft, resting on the semi-molten layers beneath, and under the trillions of tons of the Laurentide and Fennoscandian ice sheets, the land bowed. Great depressions formed, vast bowls pressed into the bedrock, shaping the basins that would one day hold the Great Lakes and the Baltic Sea. The Earth is still rebounding from this weight today, rising slowly, millimeter by millimeter, shaking off the memory of the burden it carried for so long. But back then, the burden was absolute. The ice buried everything. It did not care for the forests of spruce and fir that once grew there. It simply sheared them off, grinding the trees into splinters and then into dust, mixing them with the soil and the stones to create a thick, chaotic layer of debris known as till. It planed the tops off mountains. It gouged out valleys. It acted as a giant eraser, wiping the slate of the northern hemisphere clean, resetting the landscape for whatever would come next. And yet, there is a strange beauty in this devastation. The light on the ice fields at dawn is a spectrum of pinks and soft violets, a watercolor painting on a canvas of snow. The way the wind sculpts the drifts into waves known as sastrugi creates a frozen sea of ridges and valleys that mimic the ocean, hard as stone but looking as fluid as water. It is a place of peace in a way, a terrifying, lethal peace, but peace nonetheless. There is no conflict here, No predator hunting prey, no struggle for resources, only the simple, brutal physics of water and cold. It feels eternal. Standing here, in the center of the ice sheet, with the white horizon stretching infinitely in every direction, it is impossible to imagine that this could ever end. The cold feels like the final answer to the question of the Earth. The feedback loops are locked tight. The white surface reflects the sun, keeping the planet cool, which allows more ice to grow, which reflects more sun. It is a self-reinforcing fortress, a castle that builds its own walls. This was the mechanism of the rule. Once the ice established itself, once it reached a certain critical mass, it became the master of the climate, dictating the winds, the ocean currents, the temperature of the entire globe. It seemed unbreakable. It seemed that the Earth had finally found its resting state, a frozen equilibrium that would last until the sun itself burned out. But the universe is full of slow, subtle clocks, and even here, in the heart of the eternal winter, a countdown was ticking. The empire of the white was mighty, but it was built on a foundation of borrowed time, subject to forces that originated millions of miles away in the dark silence of space. We look down at the ice, at its hard, unyielding surface, and we see strength. But nature sees something else. It sees a reservoir, a bank account of energy and water waiting to be spent. And just as the ice seemed most permanent, most invincible, the gears of the sky were slowly, quietly shifting into a new alignment. The sun, which had been held at bay for so long, was beginning to change its angle, a shift so slight it would be imperceptible to the eye, yet powerful enough to challenge the empire. The retreat would not be a battle of armies, but a battle of light. And as we drift away from the high plateau, letting the wind carry us back toward the warmer lower lands, we can almost feel the tension building, the stored potential energy of a frozen world waiting for the signal to break. The rule had held for 8 cycles. The ice had always won. But the thing about cycles is that they are circles, and circles eventually return to where they began, bringing an end to even the longest, deepest winters. It begins not with a roar, but with a whisper, a sound so small it would be lost in the vast howling silence of the glacial wind, were you not listening for it with the attentiveness of a hunter. It is the sound of a single drop of water, freed from its crystal prison, falling onto stone. Then another. Then a trickle, a faint glassy musicality that signals the breaking of the long fever. We call this phase the Great Retreat, but the word retreat suggests an organized withdrawal, a disciplined army marching backward in good order, preserving its lines and its dignity. What happens to the ice is not a retreat, it is a rout, a collapse, a disorderly surrender to the rising heat that undoes in a few thousand years what took 90,000 years to build. This is the jagged asymmetry of the Ice Age rule, the sawtooth pattern that scientists trace on their charts with a mixture of fascination and dread. The slow, grinding climb into the deep freeze, lasting for eons, followed by a sudden precipitous plunge into warmth. If the growth of the ice is a long, laborious inhale, the melt is a sharp, desperate gasp. The sun, once a cold white disk in a pale sky, begins to feel different on the skin, carrying a weight of radiant energy that the ice can no longer shrug off. The surface of the great white sheet, which had deflected the solar fire for so long, begins to soften. The sharp ridges of the sastrugi slump, the pristine white turns to a slushy gray as dust and ancient debris, trapped for millennia, rise to the surface. And then the blue lakes appear. If you were flying over the ice sheet during this time, you would see them staring back at the sky like sapphire eyes opening in the face of a sleeper, vast pools of meltwater gathering in the depressions of the glacier. They are beautiful, breathtakingly clear and still, but they are also the agents of destruction. Water is heavy, and water seeks the deep. These lakes do not just sit on the ice, they burrow into it. They find microscopic cracks, invisible weaknesses in the structure of the frozen continent, and they begin to drill. We call them moulins, vertical shafts, round as wells, into which the meltwater pours with the force of a waterfall, spiraling down, 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 piercing a mile of ice to reach the bedrock below. When the water hits the bottom, it does something catastrophic to the stability of the empire. It lubricates the floor. The friction that held the ice sheet in place, the grit and grind of rock against rock that anchored the mountain of frozen water, is suddenly gone. The ice sheet is no longer sitting on land. It is floating on a hidden sea of high-pressure mud, and so it begins to run. The slow creep turns into a slide, the slide into a surge. The edges of the ice sheet where it meets the ocean begin to fracture violently, birthing armadas of icebergs that drift out into the Atlantic, ghost ships of white carrying cold, fresh water far into the salty currents. This is a time of immense chaotic energy. Rivers that have no names and will leave no maps burst from the toes of the glaciers, carving canyons through the bedrock in a matter of weeks, carrying boulders the size of houses as if they were pebbles. The channeled scablands of North America are the scars of these sudden violences, places where ice dams broke and unleashed floods of biblical proportions, walls of water hundreds of feet high thundering toward the sea, scrubbing the earth down to the bone. Yet, even in this turmoil, there is a strange, heavy slowness to the process from the perspective of a human lifetime. A person might live their entire life on the edge of the retreating ice and see only that the summer melt streams are running faster, that the glacier is a mile further back than it was when their grandfather walked this path. They would notice the birds returning. That is one of the first signs of the broken rule, the sky filling with wings, geese, swans, ducks, millions of them, following the retreating winter north, their calls echoing over a landscape that is waking up from a near-eternal sleep. The smell of the world changes entirely. The sterile, metallic scent of ozone and snow is replaced by the rich, rot-sweet smell of wet earth, of mud that has not seen the sun in 1,000 centuries, releasing its ancient gases. Grasses spring up in the wake of the ice with frantic speed, colonizing the raw, scraped rock, followed by scrub willow and birch, a green fuzz softening the harsh gray lines of the deglaciated land. But the most profound change is not on the land, but in the water. As the ice melts, it has to go somewhere. The oceans, which had been drained to build the white empire, begin to rise. It is a slow, relentless reclaiming. The vast coastal plains where mammoths grazed and humans built their fires, Doggerland connecting Britain to Europe, Beringia connecting Asia to America, are swallowed. The sea creeps inland, inch by year, turning hills into islands and valleys into straits. It is a quiet apocalypse for the creatures of the lowlands, a world disappearing not by fire, but by the gentle rising tide. Myths of great floods are born in these millennia, stories passed down around fires about the time the water came and never left, about the ancestors who walked on dry land where now there are only waves. This period of melting, this termination, is the breaking of the spell. The feedback loops that kept the planet cold suddenly reverse. The melting ice reveals dark land and dark water, which absorb more sunlight, which causes more melting, which reveals more dark land. The system flips, the resistance of the climate collapses. It is a cascading failure of the cold, a domino effect that runs its course until the great northern sheets are reduced to remnants, hiding in the high latitudes of Greenland and the remote archipelagos of the pole. The 100,000-year cycle has reached its crescendo. The 90,000 years of patience, of slow accumulation, of silence, are undone by 10,000 years of heat and motion. It feels like a liberation, a victory of life over the sterile stillness of the cryosphere. The forests march north, the animals expand their territories, and the world enters the interglacial, the brief, warm summer of the geological year. We live in such a summer now. We assume this warmth is the norm, the baseline state of our planet, because it is all we have ever known. But the deep history whispers a different truth. The warmth is the anomaly. The warmth is the exception. The ice is the rule. The retreat is a temporary reprieve, a breath taken before the plunge. Or at least, that is what the rhythm of the past tells us should happen. As the last of the great meltwater lakes drain away and the sea levels stabilize, the Earth settles into a period of balmy stability. The violence of the melt fades into memory, leaving behind a transformed geography, a world of new coastlines and new rivers. The mechanism that drove this great reversal, that commanded the ice to flee, seems almost magical in its power. What force could possibly be strong enough to break the back of the ice empire? What energy source could penetrate the white shield and turn the world from a freezer into a garden? The answer lies not on the Earth, but above it. The Great Retreat was not a decision made by the planet, but a reaction to a signal sent from the dark void, a message delivered by the sun, whispered across 93 million miles of space. The ice did not simply give up, it was pushed. And to understand the hand that pushed it, we must leave the wet, greening earth and turn our eyes to the geometry of the heavens, where the true clock of the ice ages ticks in a silence even deeper than the snow. We leave the wet, greening earth behind now, drifting upward until the roar of the melting floods fades into nothingness, until the atmosphere thins to a fragile blue ribbon against the black. And finally, we are out in the silence. Here, in the vast velvet quiet of space, there is no wind, no weather, no sound of ice fracturing in the dark. There is only the steady, blinding light of the sun and the heavy, invisible hand of gravity. It is here, in this cold void, that the true history of the ice ages is written. We tend to think of the Earth as an isolated vessel, a lonely ship sailing through the dark with its own internal engine, generating its own heat and storms from within. But the Earth is not independent. It is a captive, a dancer held in a tight embrace by the star that burns 93 million miles away. The relationship between the Earth and the sun is the single most important fact of our existence. It is the source of every wind that blows, every wave that crashes, every leaf that unfurls in the spring. And for a long time, we believed this relationship was constant, a fixed marriage of stone and fire that never wavered. We imagined the Earth tracing a perfect circle around the sun, year after year, receiving a steady, unchanging stream of warmth. It is a comforting thought, a vision of cosmic stability. But the universe does not deal in perfect circles, and it does not deal in stability. The truth is that the Earth is restless. It is a nervous traveler. As it journeys through the vacuum, it twitches, it wobbles, and it sways, responding to the subtle gravitational tugs of its neighbors, the massive brooding Jupiter and the ringed Saturn, who pull at our little blue world like distant tides. These pulls are gentle, almost imperceptible, but over the vast stretches of deep time, they add up to a complex shifting rhythm, a celestial clockwork that alters the way sunlight touches the planet. This is the distant whisper. It is not a shout. The sun does not suddenly flare up or dim down. The total amount of energy the Earth receives barely changes at all. Instead, it is a redistribution, a slight shift in where and when the heat arrives, a trick of geometry that creates the difference between a tropical paradise and a frozen wasteland. To understand the 100,000-year rule, we must look at the longest and slowest of these rhythms, the shape of the path itself. We are taught in school that the Earth orbits in an ellipse, an oval, but in our minds we smooth it out into a round loop. In reality, the orbit breathes. Over a cycle of roughly 100,000 years, that familiar haunting number, the Earth's path stretches and relaxes. Sometimes, under the gravitational influence of the gas giants, the orbit becomes more circular, keeping the Earth at a relatively constant distance from the sun. But then, slowly, inexorably, it is pulled outward, stretching into a more exaggerated oval, an eccentric path that takes the planet farther away into the cold dark before whipping it back in close. This is called eccentricity. It is the baseline of the celestial song, the deep, low thrum that underpins everything else. When the orbit is most elliptical, the Earth travels through a region of space that is slightly more distant, slightly colder for part of the year. It seems like such a small thing. The difference in sunlight is a fraction of a percent, a rounding error in the grand energy budget of the solar system. A modern engineer looking at the numbers might laugh and say it is negligible. that it shouldn't matter. And on a dead rock like the moon, perhaps it wouldn't. But the Earth is not a dead rock. It is a sensitive, reactive system, a planet poised on a razor's edge. It listens to the whisper. When the orbit stretches, when the Earth spends just a little more time in the shadows, the planet notices. The summers in the north become a tiny bit cooler. The sun feels a tiny bit weaker on the skin. It is not enough to freeze the world overnight, but it is enough to survive. And that is the secret key to the ice ages. It is not about harsh winters. Everyone assumes an ice age begins with a winter that is incredibly cold, a day after tomorrow freeze that snaps trees and buries cities. But the winter doesn't matter. Winters are always cold enough to make snow. The ice age is born in the summer. It is born when the summer is too weak to melt the snow that fell the winter before. That is the whisper's command. The eccentricity of the orbit creates a situation where the summer sun, just for a moment in geological time, is too faint to finish its job. A patch of snow in a shadowed valley in Canada or Scandinavia survives through July, then through August. Then September brings the fresh frost. That old snow is now the foundation for the new snow. It reflects the sun, cooling the air around it, making it even harder for the next summer to melt it. The whisper becomes a murmur, the murmur becomes a voice, and the voice becomes a shout. The 100,000-year cycle of the orbit aligns perfectly with the growth of the ice sheets, not because the orbit is the strongest force, but because it sets the tempo for this delicate failure of the summer melt. It is a ghost in the machine of our climate. We look up at the sun and see a constant friend, but the ice sheet saw a fickle companion, one that drifted away just often enough to let the cold take hold. It is humbling to realize that the miles of ice that crush the continents, the rise and fall of global oceans, the extinction of megafauna, and the migration of our own ancestors were all dictated by the slight elongation of an invisible line drawn through space. The Earth is not merely a stage for life, it is a puppet dancing on strings of gravity, responding to a rhythm that was set in motion billions of years before the first snowflake ever fell. This 100,000-year breath of the orbit is the reason the rule existed. It provided the container, the time frame within which the ice could grow and collapse. But eccentricity is not the only rhythm. It is the longest, the slowest, the background hum. There are other cycles, faster and sharper, that ride on top of it, complicating the dance, adding syncopation to the beat. The Earth does not just move in an oval, it tilts and it wobbles. And while the stretching orbit set the stage for the 800,000-year rule, it was the interplay of these other movements that determined the texture of the seasons, the harshness of the wind, and the exact moment when the ice would finally break. We float here in the silence, watching the blue marble spin, and we can see that it is not spinning perfectly upright. It is leaning. And in that lean lies the story of the seasons themselves, another layer of the cosmic code that the ice sheets learned to read long before we did. The sun whispers, but the Earth nods in response. If you could stand outside of time and watch the Earth spin, not for a day, but for an eon, the first thing you would notice is that the planet is never truly still, never perfectly balanced, for it possesses a restless, shifting posture, a physical leaning that defines the nature of every season that has ever passed. We call this the axial tilt, or obliquity, and it is the second hand on the great clock of the ice ages, a rhythm that moves faster than the slow stretch of the orbit, but still operates on a scale that dwarfs human history. Imagine a spinning top on a table, humming as it turns. When it is spinning fast and true, it stands almost upright, but as it slows or as forces push against it, it begins to list, to cant to one side. The Earth is that top. It does not spin straight up and down relative to the sun. It leans over, currently at an angle of about 23.5 degrees. This lean is the reason we have seasons at all. Because the Earth is tilted, the northern hemisphere bows toward the sun for half the year, drinking in the warmth of summer, and leans away into the dark for the other half, accepting the cold of winter. But this angle is not fixed. It is breathing. Over a cycle of roughly 41,000 years, the Earth nods up and down, rocking gently back and forth like a ship on a slow swell. The angle shifts between roughly 22 degrees and 24.5 degrees. It seems like a tiny difference, a mere 2 degrees of movement, the kind of adjustment you might make when straightening a picture frame on a wall, but to the climate, it is everything. This nod controls the intensity of the seasons. When the tilt is high, when the Earth leans far over, the seasons become extreme. The summers are hotter because the sun is higher in the sky, beating down directly on the ice. The winters are colder because the pole is turned further away into the shadow. This is the enemy of the ice. High tilt means hot summers, and hot summers, as we have seen, are the destroyers of glaciers. They melt the snow of the previous winter, stripping the land bare, resetting the clock. But when the tilt is low, when the Earth stands straighter on its axis, the seasons soften. The difference between summer and winter blurs. The summers become cool, mild, and forgiving. The sun never gets quite high enough to deliver a killing blow to the snowpack. The snow that fell in January sits there in July, reflecting the weak sunlight, surviving until the next winter arrives to bury it deeper. This is the sweet spot for the cryosphere. The 41,000-year cycle of the tilt is a pulse of ice-building potential. For millions of years, this was actually the dominant rhythm of the Earth, the primary conductor of the climate orchestra, a time when the ice grew and shrank in lockstep with this nodding motion. But in the era of the 800,000-year rule, the tilt was demoted. It became a secondary player, a modulation within the longer, deeper cycle of eccentricity, yet it never stopped working. It is the texture of the Ice Age, the reason why the long cold was not a smooth, unbroken line, but a jittery, fluctuating struggle. And there is yet another motion, a third rhythm that complicates the dance even further, a movement so subtle and disorienting that it changes the very stars we steer by. This is precession, the wobble. Go back to that spinning top. As it leans, the handle of the top doesn't just stay pointing in one direction, it traces a slow circle in the air. The axis of the Earth does the same. It does not point at the same star forever. We grow up believing that Polaris is the North Star, the fixed point of the heavens, the one true constant in a turning sky. Sailors have navigated by it for thousands of years. We build our myths and our metaphors around its reliability. But Polaris is a temporary king. The Earth's axis is slowly drawing a circle in the sky, a loop that takes roughly 23,000 years to complete. Thousands of years ago, the North Star was Thuban, a faint star in the tail of the dragon. In 12,000 years, it will be Vega, a brilliant blue-white diamond in the constellation of the Lyre. This wobble changes not the angle of the seasons, but their timing. It determines where the Earth is in its orbit when the seasons arrive. Right now, the northern hemisphere experiences winter when the Earth is actually closest to the sun in its elliptical orbit, and summer when it is furthest away. This moderates our climate, making the winters slightly milder and the summers slightly cooler than they would otherwise be. But the wobble moves the calendar. 10,000 years from now, the situation will be reversed. The north will tilt toward the sun at the exact moment the Earth is closest to the star, creating summers of intense, blistering heat. This is the wobble's power. It can amplify the tilt or dampen it. It can align with the eccentricity or fight against it. When these three cycles, the stretch of the orbit, the nod of the tilt, and the wobble of the axis, align in just the right way, they create a perfect storm of cooling. They conspire to create a world where the summer sun is distant, low, and brief. This is the astronomical trigger. It is a moment of celestial weakness, a dimming of the fire that allows the ice to make its move. It is dizzying to think of the Earth this way, as a tumbling, nodding, wobbling gyroscope drifting through the void, its climate determined by the chaotic interplay of three different clocks ticking at three different speeds. It makes the stability of our ground feel like an illusion. We are riding on a carnival ride that moves so slowly, we have mistaken it for stillness. And yet, there is a mystery here that kept scientists awake at night for decades. We know these cycles exist. We can calculate them with the precision of a master clockmaker. We can look back 800,000 years and see exactly how the Earth was tilted and where it was in its orbit. And when we look at the math, something doesn't add up. The changes in sunlight caused by these cycles are real, but they are incredibly small. The forcing, as scientists call it, the amount of extra energy added or subtracted from the system, is faint. It is a whisper, a nudge, a candle flickered in a vast cold room. By all the laws of simple physics, these tiny astronomical shifts should have caused tiny climate shifts, perhaps a slightly colder winter or a slightly wetter summer. They should not have been enough to bury half a continent under 2 miles of ice. They should not have been enough to lower the oceans by 400 feet. The signal is too weak. The effect is too massive. It is as if someone tapped a mountain with a hammer and the mountain crumbled to dust. There is a missing piece of the puzzle, a hidden amplifier buried somewhere in the Earth's own machinery that took this faint signal from space and turned it into a deafening roar. The ice did not just listen to the sun, it took the suggestion and ran with it, spiraling out of control, building a feedback loop that grew louder and louder until it drowned out everything else. To understand how the rule held for so long, we must stop looking up at the stars and look down into the white mirror of the snow itself, where the true secret of the amplification lies waiting in the glare. There is a stillness at the heart of this story that is not the stillness of peace, but the stillness of a held breath, the suspended tension of a question that hangs in the air without an answer. We call it the mystery of the weak signal, or in the hushed corridors of paleoclimatology, the 100,000-year problem, and it is perhaps the most elegant riddle the Earth has ever posed to those who try to understand her. We have spoken of the great celestial engines, the orbit, the tilt, the wobble, as if they were powerful gods commanding the planet to freeze or thaw. We imagine them as heavy levers pulled by the gravity of Jupiter, shifting the climate with irresistible force. But when we actually sit down with the numbers, when we measure the raw energy of these cycles, the story refuses to make sense. The math, quite simply, does not fit the mountain. Of the 3 cycles, eccentricity, that slow stretching of the Earth's orbit from circle to oval and back again, is by far the weakest. In terms of pure solar radiation, the change it causes is infinitesimal. It is a fluctuation of less than 0.1% in the total sunlight hitting the Earth. To put this in human terms, imagine you are sitting in a room lit by 100 blazing candles. If someone were to light one more small match in the corner, or snuff one candle out, you would barely notice the difference in the overall brightness. The room would not suddenly plunge into darkness. The temperature would not drop. It is a ghost of a change, a rounding error in the energy budget of a solar system. And yet, for the last 800,000 years, this tiny, fragile signal has been the dictator of the world. It drowned out the stronger signals. It ignored the loud shouting of the axial tilt, which changes the sunlight far more dramatically, and instead tuned itself to the faintest whisper in the room. This is the paradox that kept scientists awake late into the night, staring at charts where the jagged lines of ice volume matched perfectly with the smooth, weak curve of eccentricity. It shouldn't happen. In a linear world, a small push should result in a small movement. If you tap a boulder with your finger, it does not roll down the hill. If you whisper at a storm, it does not change direction. But the climate of the Earth is not linear. It is a beast that defies simple logic, a system where the relationship between cause and effect is not a straight line, but a tangled web of triggers and traps. We must change the way we think about power. We tend to equate power with force. The harder you hit, the bigger the impact. But in the deep time of the Earth, power is often a matter of timing and leverage. Think of a child on a playground swing. The child is heavy, and the swing is still. If a strong man walks up and shoves the swing once with all his might, the child will lurch forward, perhaps fly up a few feet, and then settle back down. The energy is spent. But think of a gentle breeze, or a very weak hand that gives the swing a tiny push. It barely moves. But if that push comes again, at the exact moment the swing starts to move forward, and then again, and again, catching the rhythm, synchronizing with the natural motion of the pendulum, that tiny push can eventually send the child soaring high into the air. This is resonance. It is the ability of a weak periodic signal to amplify itself until it shakes the foundations of the system. The eccentricity cycle is that weak hand. It is not strong enough to freeze the world on its own, far from it. But it is persistent. It provides a long, slow container of time, a 100,000-year window that allows the Earth's internal systems to build upon themselves, layer by layer, cold upon cold. It is a pacemaker. It doesn't drive the heart, it simply sets the rhythm that the heart chooses to follow. There is a sense of vulnerability in this realization. We like to think the Earth is robust, that it takes a catastrophe like a giant asteroid or a massive volcanic eruption to change its state. But the history of the ice tells us that the planet is incredibly sensitive, almost twitchy, waiting for a reason to change. It suggests that the climate system exists in a state of precarious balance, like a ball sitting at the top of a sharp peak. It takes very little energy to roll it off one side into the valley of the ice, or off the other into the valley of the hothouse. The weak signal of the orbit was just enough to nudge the ball. But this still leaves a lingering question, a shadow in the explanation. Why did the rule change? We know that before this 800,000-year era, the Earth listened to the stronger signal, the 41,000-year tilt. It behaved rationally. It followed the louder command. Then, seemingly without any external reason, it switched its allegiance to the quiet signal. It stopped reacting to the short, sharp shocks and started settling into the long, deep comas of the 100,000-year cycle. Historians of the Earth still debate whether this was a gradual shift or a sudden snap, a mid-Pleistocene transition that rewired the planet's thermal machinery. Perhaps the continents drifted just enough to change the ocean currents. Perhaps the bedrock of North America was ground down by earlier glaciers, changing the way the ice sheets stuck to the land. We may never know the precise trigger, but we know the result. The Earth entered a phase of amplification. It turned itself into a giant listening device, tuned to the frequency of the 100,000-year orbit. It took that 0.1% change in sunlight and multiplied it, magnifying it through the lens of its own atmosphere and oceans until it became a global freeze. It is a lesson in humility. It reminds us that in a complex system, size does not equal significance. A single stone can divert a river if it is placed in the right spot. A single degree of temperature can be the difference between rain and snow, between water that flows and water that stays. The mystery of the weak signal teaches us that the Earth is not a passive victim of the sun. It is an active participant, a co-author of its own climate history. It takes the raw materials given by the solar system, the light, the heat, the gravity, and spins them into something entirely its own. And the primary tool it uses for this magic trick, the mechanism that allows a whisper to become a shout, is the simple, blinding power of reflection. The weak signal starts the cooling, but it is the Earth itself that finishes the job, using a force that is hidden in plain sight, covering the landscape in a blanket of white. We look down again at the snow, at the way it hurts our eyes even in the dim light, and we realize that this brightness is not just a color. It is a weapon. It is the shield that the Earth raises against the sun, the mirror that turns the weak signal into an unbreakable rule. The ice does not just sit there, it fights back. And in that fight, in that relentless rejection of heat, lies the secret of how the winters grew so long and so deep. We stand now in a world of absolute light, a brilliance so intense that it feels less like illumination and more like a physical pressure against the eyes. We have spoken of the cold, of the wind, of the slow ticking of the celestial clock, but we have not yet spoken of the glare. To understand how the ice conquered the world, we must understand the power of whiteness, for in the deep physics of the climate, color is destiny. We are used to thinking of snow as a decoration, a soft blanket that falls to make the world pretty for a season, but on the scale of the ice ages, snow is not a blanket. It is a mirror. This is the albedo effect, a name that sounds technical but is really just the ancient Latin word for whiteness. It is the measure of how much a surface reflects the gift of the sun. Imagine you are walking through a deep, dark pine forest in the height of summer. The ground is shadowed, the needles are brown and green. The soil is black. When the sunlight hits this dark world, the forest drinks it in. It absorbs the energy, holding it in the earth, warming the air, creating a bubble of heat that sustains life. The ocean does the same. The deep blue water is a sponge for solar energy, soaking up the warmth and storing it in its depths. These dark surfaces are the friends of the sun. They accept what is offered. But ice is a rejection. Ice is a shield. When the sun strikes the vast, pristine surface of the glacial sheet, 80 to 90% of that energy is slammed shut, bounced instantly back up through the atmosphere and out into the cold void of space. It is a cosmic refusal. The heat touches the earth but is not allowed to stay. It is sent away, leaving the surface beneath it as cold as it was before. This is the great amplifier, the mechanism that took the weak signal of the orbit and turned it into a planetary freeze. It explains the mystery of how a small nudge can cause a massive collapse. Think of it as a conversation between the earth and the sky. The orbit whispers, "Let it be a little cooler this summer." The earth responds by allowing a patch of snow to survive in a high valley. That patch of snow is small, perhaps only a few miles wide, but it changes the rules of the neighborhood. Because it is white, it reflects the sun. The air directly above that patch of snow becomes colder than the air above the bare rock next to it. Because the air is colder, the snow does not melt. In fact, it encourages more snow to fall. The patch grows. It merges with the patch in the next valley. Now you have a snowfield. The snowfield reflects even more sunlight, creating a larger dome of cold air. The cooling spreads. It is a contagion of cold. This is the positive feedback loop, the engine of the ice age. Once the process begins, it feeds itself. The more ice there is, the more sunlight is reflected. The more sunlight is reflected, the colder the planet gets. The colder the planet gets, the more ice grows. It is a runaway train, gathering speed with every mile it travels down the track. It explains why the ice ages, once they started, were so hard to stop. The Earth was painting itself white, locking itself into a state where it could no longer accept the warmth that might save it. There is a terrifying simplicity to this logic. It suggests that the climate has a memory, that it remembers the snow of yesterday and uses it to build the snow of tomorrow. It implies that there is a tipping point, a threshold of whiteness. If the ice stays below a certain line, the dark land can fight back, absorbing enough heat to melt the edges. But if the ice crosses that invisible line, if it covers enough ground to reflect a critical amount of sun, the balance tips. The dark land loses the battle. The mirror becomes too large to break. We can imagine the view from space during the height of the rule, a planet that looks less like a blue marble and more like a frosted eye, the white cap spreading down from the north like a cataract, blinding the hemisphere to the sun. It is a lonely image. It suggests a world turning inward, closing itself off from the rest of the universe, wrapping itself in a cold shroud of its own making. And down on the surface, this effect creates a unique sensory experience. The cold of the Ice Age was not just a temperature, it was a quality of the light. The sun, even on a clear day, would feel distant, stripped of its power. You could stand in the full glare of noon, surrounded by diamonds of frost, and feel no warmth on your face, only the sharp bite of the wind. The light would come from everywhere, from the sky, from the ground, from the clouds, a 360-degree illumination that cast no shadows and offered no comfort. It is a sterilization of the landscape. And yet, this mirror was not the only tool the Earth used to lock in the cold. A mirror can reflect light, but it cannot change the air itself. It can reject heat, but it cannot trap the cold that is already there. For the rule to hold for 80,000 years at a time, for the ice to grow 2 miles high, the Earth needed to do more than just reflect the sun. It needed to change the very atmosphere. It needed to adjust the thermostat of the planet. As the white sheets spread, pushing the forests back and covering the oceans, another transformation was taking place, invisible and silent, deep in the lungs of the world. The air was getting thinner, not in oxygen, but in the invisible blanket of gases that keeps us warm. The mirror of the snow was powerful, yes, but it was working in concert with a much deeper, darker partner, a shift in the chemistry of the deep ocean that would slowly, methodically, suck the heat-trapping carbon out of the sky and bury it in the abyss. We turn our eyes now from the blinding white surface, from the glare that hurts to look at, and look toward the dark rolling waters of the southern oceans, where the next secret of the Ice Age lies hidden in the waves. The mirror reflected the heat, but the ocean stole the blanket. And together they ensured that the winter would last for an eternity. We leave the blinding glare of the ice fields now and descend past the howling winds of the glacial edge, past the dry tundra where the mammoths walk with their heads bowed against the gale, and we come to the edge of the world's other great power, the ocean. If the ice sheet is the shield that deflects the sun, the ocean is the lung that regulates the breath of the planet. It is dark here, a restless, heaving expanse of steel-gray water under a leaden sky, stretching to a horizon that feels infinite and lonely. The waves are high, driven by winds that have no land to break them, rolling in long, muscular swells that carry the energy of storms born thousands of miles away. It is easy to look at the ocean and see only water, wet and chaotic, but in the story of the Ice Ages, the ocean is the keeper of the secret vault. It is the reason the cold, once it arrived, could not easily leave. To understand this, we must visualize the atmosphere not as empty space, but as a blanket. Wrapped around our planet is a fragile layer of gases, nitrogen, oxygen, and the crucial trace amounts of carbon dioxide that acts as insulation. It lets the sunlight in, but it catches the heat trying to escape, holding it close to the surface like a quilt on a winter night. Without this invisible blanket, Earth would be a frozen rock, a lifeless ball of ice spinning in the void. But the blanket is not fixed. It can be thick or it can be thin. And during the time of the rule, during those long, deep 100,000-year winters, the blanket was pulled threadbare. The Earth was stripping off its own insulation, deliberately exposing itself to the cold of space. We know this because the ice tells us. When scientists melt those ancient cores drilled from Antarctica, they release bubbles of air that were trapped 800,000 years ago, and they find a stark, repeated truth. Whenever the ice was high, the carbon dioxide was low. It dropped from the warm, comfortable levels of the interglacials down to a starving, breathless low of 180 parts per million. It is a number that spells deep freeze. But where did the carbon go? It cannot simply vanish from existence. Matter is neither created nor destroyed. The answer lies beneath the waves rolling below us. The ocean drank it. There's a simple rule of physics that you can observe in a glass of soda. Cold liquid holds gas better than warm liquid. As the Earth cooled, nudged by the orbital cycles and the spreading white mirror of the ice, the oceans grew colder. And as they chilled, they became thirstier for the atmosphere's carbon. They absorbed it, pulling the heat-trapping gas out of the sky and locking it away in the water. But this was only the first step, the physical inhale. There was a second, deeper mechanism at work, a biological alchemy happening in the sunlit surface waters. In the dry, windy world of the Ice Age, dust was everywhere. The glaciers ground rock into flour, and the fierce winds whipped it up into giant clouds that drifted out over the oceans. This dust was rich in iron, a vital nutrient for the microscopic life of the sea. When it settled on the water, it triggered an explosion of life. Trillions of tiny plankton bloomed, a vast invisible forest floating in the waves, drinking the sunlight and absorbing carbon to build their tiny bodies. When they died, they did not dissolve. They sank. Imagine a snowfall in the ocean, a marine snow of organic flakes drifting down into the crushing darkness, carrying the carbon they had harvested from the sky down to the bottom of the abyss. This is the biological pump, the heartbeat of the deep. For thousands of years, this rain of dead carbon continued, sequestering the warmth of the world in the mud of the ocean floor, locking it away where it could not touch the atmosphere. The ocean was hoarding the heat-trapping blanket, burying it mile by deep mile. And there is one final specialized player in this theft, the Southern Ocean. Encircling Antarctica, this ring of violent churning water acts as the primary window between the deep sea and the sky. During the ice ages, the sea ice around Antarctica expanded dramatically, capping this ocean like a lid on a jar. The winds shifted, the currents slowed, and the deep carbon-rich water was trapped. It could not rise to the surface to exhale its gas back into the air. The door was closed. The Earth was effectively holding its breath. This is why the rule of the 100,000 years was so stable. It wasn't just about the ice reflecting the sun. It was about the atmosphere losing its ability to hold heat. The system had a double lock. Even if the sun grew a little stronger, the low carbon levels meant the heat couldn't stay. The Earth had created a perfect self-reinforcing refrigerator. It is a haunting thought that the life in the oceans, the tiny, mindless plankton, were unwitting architects of the freeze, working tirelessly to scrub the sky clean of the very thing that kept the planet warm. It feels like a conspiracy of nature, a coordination of rock, wind, water, and life, all moving toward a single goal: maximum cold. We float here, over the gray swell, and we can almost feel the heaviness of the air, the thinness of the thermal protection. The world feels exposed. It feels brittle. The ocean, usually a symbol of chaos and motion, becomes a symbol of storage, a vast, cold warehouse where the potential for summer is locked away in the dark, waiting for a key that will not turn for millennia. This interaction between the atmosphere and the deep ocean is slow. It takes roughly 1,000 years for water to circulate from the surface to the bottom and back again. This sluggishness matches the rhythm of the ice. It explains why the climate doesn't jump, but drifts. It takes time to fill the deep ocean with carbon, and it takes time to release it. The breath of the deep is a slow, rhythmic respiration, one inhale every 100,000 years. And while the ocean was pulling the blanket down, something else was happening on the land, something equally slow and equally massive. We have spoken of the ice as a covering, a surface feature, but we must remember its weight. Ice is heavy. Water weighs 8 pounds per gallon, and a glacier is a river of solid water miles thick. When you pile that much mass onto a continent, the continent does not just stand there, it reacts, it bends. The Earth is not a solid, unyielding rock. It is elastic, a crust floating on a mantle of hot, viscous putty. And under the crushing burden of the Ice Age empire, the land itself began to sink, reshaping the geometry of the planet and adding one final strange twist to the rule of the cold. We turn now from the dark water to the suffering land, to witness the Earth groaning under the weight of its own frozen armor. We have felt the cold of the wind and the spray of the gray ocean, but to truly understand the grip of the ice, we must go deeper, descending beneath the snow, beneath the soil, down into the bedrock itself. We must imagine the Earth not as a planet of solid stone, but as something more yielding, something that groans and bends under pressure. We stand now on the edge of a continent that is vanishing, not washing away, but sinking. This is the story of the heavy Earth, the physical memory of weight that the planet carries in its very bones. It is difficult for us to comprehend the sheer mass of the ice sheets that define the 100,000-year rule. We see them as frozen water, and water seems light, buoyant, something that flows and splashes. But water is heavy. A single cubic yard of ice weighs nearly a ton. Now imagine that cubic yard multiplied by millions, by billions, by trillions. Imagine a layer of ice 2 miles thick, covering an area larger than the United States. The weight is beyond the capacity of human language to describe. It is a burden of such colossal magnitude that it changes the shape of the sphere. The Earth's crust, that hard outer shell we walk upon and build our cities on, is strong, but it is thin, a mere skin floating on the mantle below. The mantle is rock, yes, but under the immense heat and pressure of the deep Earth, it does not act like rock. It acts like thick, slow honey. It flows. And so, when the great ice sheets began to grow, piling layer upon layer of white darkness onto the land, the continent did not simply support them. It surrendered. It bowed down. Imagine placing a heavy bowling ball onto a soft mattress. The mattress dips, creating a cradle, a depression that holds the ball in place. This is exactly what happened to North America and Europe. Under the terrifying weight of the Laurentide and Fennoscandian ice sheets, the land sank. It was pressed down, foot by foot, mile by mile, until the surface of the continent was hundreds, sometimes thousands of feet lower than it had been before. This was not a sudden collapse, a cracking of the crust, but a slow, agonizing deformation, a geological sigh as the land gave way. If you could have stood in the silence of that time, with your ear pressed to the granite of the Canadian Shield, you might have heard it, not a snap, but a deep, resonant moaning, a vibration too low to hear, but strong enough to feel in your teeth, the sound of the planet adjusting its posture. This sinking created a strange and trap-like geometry. The ice was no longer resting on a flat surface. It was sitting in a bowl of its own making. The center of the ice sheet was anchored in a deep depression, surrounded by walls of rock that held it fast. This isostatic depression, as the scientists call it, acted as a stabilizing force. It made the ice harder to move, harder to dislodge. It cradled the cold. And because the Earth is a closed system, when the land sank in one place, it had to rise in another. The mantle, squeezed out from under the crushing weight of the glaciers, flowed sideways, deep underground, pushing up the land around the edges of the ice. This created a forebulge, a ring of rising earth that surrounded the ice sheet like a rim. Lands that are now drowned under the sea were lifted up, creating temporary bridges, temporary plains, dry and windy, where herds of reindeer grazed on hills that would one day sink back beneath the waves. It was a landscape of slow-motion waves made of solid rock, a ripple effect spreading out from the center of the cold. This warping of the earth happened with a slowness that matched the ice itself. The mantle is viscous. It resists flow. It takes thousands of years for the land to sink when the weight is applied, and thousands of years for it to rise again when the weight is removed. This lag, this delay between the cause and the effect, added another layer of inertia to the climate system. The Earth could not react quickly. It was sluggish, heavy with sleep. When the ice began to grow, the land held it up for a while, keeping the surface high and cold, encouraging more ice. Then, as it sank, the surface lowered, but the ice was already so thick that the top remained in the freezing upper atmosphere. The trap was set. The bowl was formed. And even today, we are living in the echo of this great heaviness. In places like Hudson Bay and the Gulf of Bothnia, the land is still rising, springing back slowly, inch by inch, shaking off the ghost of the ice that vanished 10,000 years ago. The harbors of Scandinavia have to be dredged, or the docks moved, because the sea bottom keeps becoming dry land. The earth remembers. It has not yet forgotten the weight that held it down for so long. This physical depression of the continents did something else, something crucial to the breaking of the rule. It changed the way the ice interacted with the ocean. As the land sank, the edges of the ice sheet in some places were pushed down below sea level. They became marine-based ice sheets, sitting on bedrock that was effectively the floor of a suppressed ocean. This made them vulnerable. If the ocean water could get in, if it could find a way to flow over the rim of the forebulge and touch the base of the ice, it could lift it. It could destabilize the whole structure from below. But for most of the 100,000 years, the weight was the master. The land accepted its burden. The continents lay quiet and low, pinned by the white giant. It is a somber image. The proud, strong mountains and plains of our world humbled, pressed down into the mantle, hiding from the sky under a blanket of miles-thick crystal. It reinforces the sense of the Ice Age not as a weather event, but as a total planetary state, a reorganization of the Earth from the atmosphere down to the molten core. Every part of the system, the air, the water, the rock, was locked in a conspiracy of stability. The air was thin of carbon, the water was cold and hoarding heat, the rock was bowed and cupped, every exit was barred, every feedback loop was closed. The system had developed a memory, a resistance to change that went beyond simple physics. It had entered a state where the past dictated the future, where the presence of ice guaranteed the persistence of ice. This is the concept of hysteresis, the idea that the path you take to get somewhere determines how hard it is to get back. The Earth had walked a long, slow road into the cold, and the road behind it had crumbled. There was no easy way to turn around. The weight of the ice had changed the map, changed the elevation, changed the very nature of the ground. And so, the rule held. The heartbeat continued, slow and steady, unpredictable, for generation upon generation, a cycle that seemed as if it had no beginning and would have no end. But as we know, the Earth is never truly static. Even in the deepest depression, even under the heaviest load, the seeds of the reversal were waiting. The lag time of the bedrock, the slow flow of the mantle, meant that the land was always out of sync with the ice, always chasing the equilibrium, but never quite catching it. And in that gap, in that mismatch between the weight of the ice and the height of the land, lay the vulnerability that would eventually help bring the walls crashing down. But for now, the weight is absolute. The Earth sleeps a heavy, dreamless sleep, wrapped in white, anchored by gravity, waiting for a signal that is still thousands of years away. We have walked the perimeter of the ice, stood beneath the blinding sun of the high plateau, and felt the Earth sinking beneath our feet, and now we must step back to see the shape of the whole. We have been speaking of parts, of orbits, of gases, of reflections, but a planet is not a collection of parts. It is a single breathing organism, and like any living thing, it has a memory. This is not a memory of thoughts or images stored in neurons and synapses, but a memory of state, a physical stubbornness that scientists call hysteresis. It is a word that sounds dry and academic, but in the context of the deep past, it is the most haunting concept of all. It means that the Earth remembers where it has been, and it prefers to stay there. It means that the path into the cold is not the same as the path out. Imagine walking through a field of tall, wet grass. As you walk, you trample a path, flattening the stalks, creating a trail. If you turn around to go back, you naturally follow the same line. It is easier. The resistance is lower. The Earth does this with its climate. Once it walked down the road into the Ice Age, it wore a groove into the reality of the planet, a deep, comfortable rut that became harder and harder to leave. This is why the rule held. The system had built so many walls around itself, the white mirror reflecting the sun, the ocean hiding the carbon, the continents bowing down, that it could no longer hear the subtle suggestions of the stars. It had become deaf to the small changes. The orbit might shift, the tilt might wobble, the sun might whisper, "Warm up," but the Earth, locked in its heavy frozen memory, simply ignored it. It had too much inertia. Think of a massive stone flywheel spinning in the dark. It takes a tremendous amount of energy to get it moving, but once it is spinning, it takes an even greater force to stop it. The Ice Age was that flywheel. For tens of thousands of years, the momentum of the cold was so great that it crushed any attempt at spring. A slightly warmer summer would arrive, driven by a shift in precession, but the ice sheet was so thick, the air so clean of carbon, the ground so white, that the warmth was swallowed up and lost. The summer would fade, the winter would return, and the wheel would keep spinning. This is why the cycles were so long. It wasn't that the sun only changed every 100,000 years. The sun changed all the time. But the Earth was so stuck, so deeply entrenched in its glacial fortress, that it ignored the smaller, faster beats of the solar rhythm. It waited. It waited for the perfect storm, the alignment of every possible factor, eccentricity, tilt, wobble, combined with the internal instabilities of the ice itself, to finally generate enough force to shatter the memory and break the wheel. This creates the sawtooth pattern of history, the long, slow, stubborn grind into the cold, where the system resists change, followed by the sudden violent snap of the termination, where the memory is finally broken and the world rushes into warmth. It is a violent amnesia. The ice melts, the carbon bursts from the ocean, the land rebounds, and for a brief moment, The Earth forgets the cold. But then, slowly, the cycle begins again. The memory starts to reform. The first snow falls and doesn't melt. The first groove is worn in the grass. This concept of system memory changes how we view the stability of our own time. We tend to think of the climate as a dial. Turn it up, it gets hotter. Turn it down, it gets colder. But hysteresis teaches us that the climate is not a dial. It is a switch, a heavy, rusty, difficult switch. You can push on it for a long time and nothing happens. You can push harder and still nothing. The system absorbs the pressure, hiding the stress, maintaining its state through the sheer force of its own inertia. And then, suddenly, with a snap that echoes through the geological record, the switch flips. The state changes. And once it is flipped, you cannot simply flip it back by removing the pressure. The rules have changed. The new state has its own stability, its own memory, its own defenses. The Ice Age was one such state, a cold mode that the Earth settled into comfortably. The interglacial, the warm garden we live in now, is the other state, a warm mode. The transition between them is not a slope, it is a cliff. And for 800,000 years, the Earth spent 90% of its time at the bottom of the cliff, in the cold, struggling to climb back up only to slide back down again. This dominance of the cold suggests that, for this era of the planet's history, the ice was the preferred state. The Earth wanted to be frozen. The feedback loops were biased toward cooling. The warm periods were merely fever dreams, brief flashes of heat in a long, dark slumber. It is a humbling perspective. We look at the ice ages as disasters, as interruptions to the normal flow of life. But to the planet, the ice was the norm. We are the interruption. We are the anomalies living in the brief, unstable moment when the memory of the cold has temporarily faded. But memories in the physical world are never truly erased. They are only buried. The conditions that created the ice, the arrangement of the continents, the circulation of the oceans, the faint signal of the orbit, are all still there, waiting. The groove in the grass is still visible if you know where to look. And yet, this heavy, stubborn, memory-laden world of the 100,000-year cycle was not always the way of things. If we drift further back in time, past the 1 million-year mark, past the era of the deep ice, we find a different planet, a faster planet. A world where the memory was not so deep, where the flywheel was lighter, where the Earth danced to a quicker, simpler beat. The rule of the 100,000 years, which feels so eternal, so unbreakable, was actually a new invention, a change in the rhythm that appeared mysteriously out of the mist of the past. Before the deep freeze, there was the time of the quick pulse. Before the heavy Earth, there was the responsive Earth. To understand why the rule broke, we must first understand the world that existed before the rule began, the earlier, lighter epoch where the ice came and went with the friendly regularity of a metronome, never staying long enough to build a fortress, never sinking the continents into the deep sleep of the long cycle. We travel back now, across the boundary of the mid-Pleistocene, to a time when the ice was merely a visitor, not an emperor. We drift backward now, slipping through the invisible curtain of time, past the 1 million-year mark into a world that feels familiar and yet fundamentally different. The silence of the great ice sheets recedes, replaced by a rhythm that is lighter, quicker, more vibrant. This is the earlier world, the era of the 41,000-year pulse. If the time of the 100,000-year rule was a deep coma-like sleep, this earlier epoch is a light doze, a series of short naps from which the Earth wakes easily and often. The landscape here is less severe. The ice still comes, yes. It is still the Quaternary period, the age of fluctuating climates. But it lacks the crushing monolithic permanence of the later years. The glaciers here are visitors, not residents. They flow down from the north, painting the mountains white, chilling the winds. But they do not stay long enough to bury the continents in a tomb of crystal. They are thinner, more fragile, more responsive to the sun. The great feedback loops, the mirrors of snow, the carbon-starved oceans are present, but they are weaker, unable to lock the planet into a deep freeze. The climate here is not a stubborn, heavy thing. It is agile. It listens. When the sun shifts, the Earth follows. This is the era where the planet danced to the beat of the axial tilt, the obliquity cycle we spoke of before. Every 41,000 years, as the Earth nodded up and down on its axis, the ice advanced and retreated in perfect synchronization. There was no mystery here, no weak signal problem. The cause matched the effect. The sun got weaker, the ice grew. The sun got stronger, the ice melted. It was a linear, logical world, a system that made sense to the laws of simple physics. The winters were cold, but not eternal. The summers were warm, and they returned on schedule. For the ancestors of humanity living in this time, the Erectus populations wandering out of Africa, exploring the greening edges of Asia and Europe, this rhythm would have felt like a constant generational truth. The world changed, but it changed within a human scale of memory, within the stories passed down from grandmother to grandchild. The sea levels rose and fell, but they did not plunge 400 feet into the abyss. The land bridges appeared and disappeared, but the continents did not sink under the weight of miles of ice. It was a gentler time. But why? What was different about this Earth? The continents were in roughly the same place. The sun was the same star. The orbit was the same oval. Why did the planet listen to the 41,000-year cycle then, and the 100,000-year cycle later? The answer seems to lie in the nature of the ground itself. In this earlier world, the northern hemisphere was dirtier. The bedrock of Canada and Scandinavia, which would later be scoured clean by millions of years of glacial grinding, was still covered in a thick ancient layer of soil, regolith. This soil was slippery. When the ice sheets tried to grow, they sat on this loose, shifting layer of dirt. They could not stick. They could not anchor themselves. As soon as they built up any significant height, the base would slide, the ice would spread out thin, and the edges would melt into the warmer oceans. The ice was unable to build the vertical height needed to create its own weather, unable to reach up into the freezing upper atmosphere to sustain itself against the summer sun. It was a thin ice world. Because the ice was thin, it was fragile. It couldn't resist the sun. When the tilt pushed the Earth back toward warmth, the thin sheets collapsed instantly. There was no hysteresis, no deep memory, no lag. The switch was easy to flip. The climate was responsive. It lacked the inertia that would later define the deep freeze. It is a strange thought that the difference between a mild, oscillating climate and a frozen hellscape might come down to something as mundane as the amount of dirt on the ground. It suggests that the Earth's climate stability was essentially eroded away, scraped off by the very ice it tried to resist. But there is a beauty in this faster rhythm. It created a world of constant motion, of biological pumping, of genetic mixing. Animals migrated back and forth, plants colonized and retreated, the pot was constantly stirred. It was a dynamic evolutionary engine. And then, something happened. A change so subtle that it left no scar in the rock, no crater, no ash layer, yet so profound that it rewrote the rules of the planet. We approach the boundary now, the invisible line in the strata known as the mid-Pleistocene transition. It is not a sudden event. You cannot point to a single Tuesday in history and say, here is where it changed. It is a drift, a slow fading of one signal and the rising of another. It is like listening to a radio where two stations are overlapping. The fast rhythmic beat of the 4,000-year cycle begins to drown in static, and through the noise, a slower, deeper, more ominous drumbeat begins to emerge. The 100,000-year signal. The ice sheets begin to hold on a little longer. They survive a summer they should have melted in. They grow a little thicker. They scrape a little deeper, removing the last of the slippery soil, finding the hard friction of the bedrock beneath. They begin to stick. The ocean currents shift, perhaps diverted by the growing ice, changing the way heat is moved around the globe. The carbon dioxide levels dip just a little lower, crossing a threshold that makes it harder for the atmosphere to recover. The system tightens. The trap begins to close. We are witnessing the birth of the rule. It is a moment of profound transformation, yet it happens without fanfare. There are no explosions, no meteors streaking across the sky. It is an internal reorganization, a shift in the planet's own metabolism. The Earth decides, if a planet can be said to decide, that it prefers the cold. It chooses stability over responsiveness. It chooses the deep sleep over the light nap. And as the transition completes, as the last of the thin ice cycles fades away, we see the first of the true giants rising in the north, the first of the megaglaciers, the continent killers, the white emperors. The frequency slows down, the amplitude shoots up. The graph of history changes from a nervous zigzag to a series of deep plunging canyons. We have left the era of the wobble and entered the era of the stretch. The 100,000-year clock has begun to tick. It is a somber realization, drifting here at the turning point of deep time. We see that the harshness of the recent past, the world our ancestors survived, the world that shaped our own evolution, was not the original plan. It was an acquired state, a habit the Earth fell into. The normal state of the quaternary was this faster, lighter rhythm. The deep freeze was a deviation that became the standard. And this transition teaches us the most important lesson of all, that the climate system is capable of fundamentally changing its operating manual. It can switch modes. It can decide that the old rules no longer apply and invent new ones. We often ask if the climate is changing, but the deeper question is the nature of the climate changing? Are we right now standing on the edge of another transition, another shift in the frequency, where the rules we have known for 800,000 years are being rewritten once again? The breaking of the rule in the Holocene, the mist ice age, suggests that the answer is yes. But to understand the break, we must first appreciate the strength of the chain. We must look at the peak of the rule, the era where the 100,000-year cycle was the undisputed master of the world, an era that seemed to everything living within it like it would last forever. We drift now into the gray mist of the Middle Pleistocene, a span of time that historians of the Earth call the transition, though it feels less like a crossing and more like a deepening, a slow sinking into a heavier, darker state of being. We are roughly 1 million years in the past, suspended in the blur where the old world of the quick light ice ages fades into the new world of the long, crushing winters. It is here, in this mysterious interval, that the rule was truly written. And the most unsettling thing about this shift is its silence. If you look at the stars during this time, nothing changes. The orbit of the Earth continues its slow stretch and relax. The axis continues to nod and wobble with the same precise rhythm it has followed for eons. The sun does not dim. The galaxy does not shift. From the outside, the inputs to the machine remain exactly the same. But the machine itself is changing. The Earth is rewriting its own software, altering the way it responds to the universe. This is the mid-Pleistocene transition, the MPT, and it stands as one of the great unsolved riddles of paleoclimatology. Why, after over 1 million years of obediently following the 41,000-year cycle of the tilt, did the planet suddenly decide to ignore it? Why did it switch its allegiance to the slower, weaker 100,000-year beat? The answer, we believe, lies not in the sky, but in the dirt. We must look down at the ground beneath the ice, at the skin of the continents. In the earlier world, as we saw, the land was covered in thick ancient soil, the regolith, a slippery layer of loose rock and clay that kept the glaciers moving, kept them thin, kept them from sticking. But ice is a relentless sandpaper. For 1 million years, every time the glaciers advanced, they scraped, they gouged, they pushed the soil into the sea, stripping the continents down to the bone. By the time we reach this transition, the work is finished. The soft, slippery skin is gone. The Canadian shield, the Scandinavian bedrock, the spine of the northern world is exposed. Hard, rough, crystalline rock. Now, when the ice returns, it finds traction, it finds friction, it anchors itself to the rough stone and refuses to move. It grows upward, building a dome of cold that reaches high into the atmosphere, creating its own weather system, its own fortress of temperature that can deflect the summer sun. The thin ice world is gone. The thick ice world has arrived. This physical change in the connection between the ice and the land fundamentally altered the timing of the climate. In the old days, When the 41,000-year tilt cycle brought a warm summer, the thin, slippery ice would collapse. But now the ice is thick. It is stubborn. It is. The tilt cycle brings a warm summer, and the ice sheet simply shrugs it off. It is too massive to melt. It survives the warmth. It skips a beat. It waits for the next cycle, and the next, growing larger and colder all the while, until only the combined force of every astronomical cycle aligning at once, the super summer created by eccentricity, tilt, and wobble working together, can finally break it down. This is how the 100,000-year rule was born. By the Earth learning to ignore the smaller signals. It is a story of thresholds. The planet's resistance to warming increased just enough that the standard solar push was no longer sufficient to flip the switch. It needed a bigger push, a longer wait, and as the ice grew larger, the other feedback loops we spoke of, the ocean carbon storage, the albedo reflection, grew stronger too. The deep ocean circulation slowed down, becoming a sluggish cold trap for carbon, pulling the greenhouse gases down to unprecedented lows. The atmospheric concentration of CO2 dropped from the relative comfort of the early Quaternary to the starving levels of the deep ice ages. The air became clearer, colder, less able to hold heat. The transition was a self-reinforcing spiral. The stripping of the soil allowed bigger ice. Bigger ice cooled the oceans. Colder oceans sucked up more carbon. Lower carbon allowed even bigger ice. The system was locking itself in. We can imagine this era as a time of confusion for the life of the planet. The herds of ancestors, the plants, the forests, they were attuned to the faster rhythm. They expected the ice to retreat after 40,000 years. But this time, the winter just kept going. The generations passed and the ice did not leave. The forests that had retreated south, waiting for the return of the warmth, found themselves trapped in a climate that was growing harsher, drier, dustier. The megafauna adapted. This is the crucible that forged the true giants of the Ice Age, the woolly mammoth, the woolly rhino, the cave bear. They were creatures built for the long haul, evolved to survive in a world where winter was not a season, but an epoch. And somewhere in Africa, a clever, upright ape was also adapting, learning that the environment was no longer a reliable friend, but a shifting puzzle that required intelligence to solve. The mid-Pleistocene transition was the engine that drove the evolution of complexity. It forced life to deal with a world of extreme states. It is haunting to realize that this great shift, this fundamental restructuring of the Earth's climate, might have been caused by something as simple as erosion, the rubbing away of the soil. It suggests that the stability of the planet is not a fixed property, but an evolving one, subject to the wear and tear of geological processes. The Earth aged. It lost its youthful flexibility. It became stiff, set in its ways, prone to long, deep silences. And once the transition was complete, roughly 800,000 years ago, the new regime was absolute. The sawtooth pattern was etched into the record. The rule was no longer a suggestion. It was the law. The 100,000-year heartbeat began to thump with a terrifying regularity. Glacial, interglacial, glacial, interglacial. A pendulum swinging through the dark, marking time on a scale that renders human history invisible. We've arrived at the peak of the rule. The machine is fully built, the gears are locked, and the world has settled into the rhythm that will define it until the very end of the story. It is a time of majestic, terrifying order. A time when the ice seems to have won the war, allowing the warmth only a brief, fleeing victory every 100 millennia. We drift forward now, into the heart of this long stability, to witness the world as it was for the vast majority of our species' existence. A world where the ice was the landlord, and we were merely the tenants living in the drafty basement. The transition is over. The deep freeze has begun. And in the silence of this new, heavier Earth, we can feel the weight of the future pressing down, a future where the only certainty is the return of the white wall. And so the world settled into the long hypnotic rhythm of the deep time, a metronome swinging back and forth in the dark, marking out the hours of the geological clock with a terrible, beautiful precision. This is the peak of the rule, the era spanning the last 800,000 years, a time when the 100,000-year cycle was not just a pattern, but a tyranny. If you were to take a step back and look at the temperature record of this period, it would look like a jagged saw blade, a long, slow, struggling climb up the slope of the cold, lasting tens of thousands of years, followed by a precipitous drop into the brief, sharp valleys of warmth. 8 times the ice sheets grew, swallowing the north. 8 times they collapsed, flooding the coasts. It became the heartbeat of the planet, a pulse so regular that if you were a creature evolving during this time, you would not know it was a cycle. You would simply know it as the way the world is. The ice was the baseline. The warmth was the anomaly. It is strange to think that for the vast majority of human existence, and for the existence of our cousins, the Neanderthals and the Denisovans, the map of the Earth looked nothing like the one we hang on our walls today. The familiar outlines of Europe and North America were erased, buried under the White Empire. The sea level was 400 feet lower. You could walk from France to England on dry land. You could walk from Siberia to Alaska. The world was bigger in a way, more land, but harder land. A colder, drier, windier place where the dust blew in great clouds that circled the globe, settling in thick layers of yellow silt called loess that we still find today, a physical memory of the dry storms of the past. It was a rigorous world, a filter that demanded excellence from everything that tried to live in it. This repetition, this endless loop of freeze and thaw, acted as a pump for evolution. Every time the ice advanced, it squeezed populations into small, isolated pockets of warmth, refugia, where they changed, adapted, and drifted apart genetically. Every time the ice retreated, these populations surged back out, mixing and mingling in the brief summer of the interglacial. It was a breeding program run by the orbit of the Earth. We are the products of this engine. The human brain, with its capacity for planning, for memory, for social cooperation, is likely a tool forged in the fires of this variability. We needed to be smart because the weather was no longer reliable on a scale of centuries, but on the scale of millennia, it was ruthlessly consistent. The rule held. It held through the rise and fall of species, through the shifting of magnetic poles, through the explosions of supervolcanoes like Toba. Nothing could break the rhythm. The feedback loops we have spoken of, the reflection of the snow, the deep storage of carbon in the ocean, the sinking of the continents, were locked in a perfect, self-reinforcing dance. The system was robust. It had found a stable groove in the chaos of the solar system, a limit cycle that it returned to again and again. Scientists call these warm periods interglacials, a word that implies they are merely interruptions, pauses between the main acts, and indeed, they were short. Of the last 800,000 years, only about 10% of the time was spent in conditions like today. The other 90% was ice. We look back at previous warm periods, the Eemian, the Holsteinian, and we see that they were feverish, intense, and brief. The Eemian, about 125,000 years ago, was actually warmer than today. Hippos swam in the Thames. Forests grew on the North Cape of Norway. The sea level was 20 feet higher, but it didn't last. The orbit shifted, the whisper of the sun changed, and the ice came back, crushing the forests, burying the hippos, resetting the clock. It feels almost fatalistic, this eternal return. It suggests that the Earth has a preferred state, and that state is cold. It suggests that warmth is fragile, a house of cards that collapses at the slightest touch, while the ice is a fortress of stone. We can imagine the generations of early humans living through the long cooling phases, the grandmothers telling stories of a time when the summers were longer, when the trees grew further north, stories that sounded like myths to the children of the tundra. They must have felt the slow constriction of their world, the way the winters bit a little harder each year, the way the game moved south. But they adapted. They followed the herds. They invented the needle to sew tight clothing. They mastered the fire. They built shelters of mammoth bone. They flowed with the ice. They did not fight the rule. They lived within it. And perhaps in their own way, they found a comfort in the reliability of the seasons, even if those seasons were harsh. There is a safety in predictability. You know that after the winter comes the spring, even if the spring is cold. You know that the sun will return. But the terrifying thing about the 100,000-year rule is not that it repeats, but that it implies a destiny. It implies that no matter how warm it gets, the ice is always waiting. It is the default, the attractor of the climate system. For 800,000 years, every single warm period ended the same way, a slow, stuttering slide back into the deep freeze. There were no exceptions. The rule was absolute. The Earth would warm up, shed its ice, breathe out its carbon, and then, as soon as the orbit aligned, it would begin the descent. It was a trap that had no exit, or so it seemed. Because as we drift toward the end of this era, toward the most recent cycle, the one that birthed our modern world, we begin to sense a change. Not in the orbit. The stars are still singing the same song. Not in the continents. They are still sitting heavy and low. But in the final swing of the pendulum, the one that brings us to the present day, something different happens. The rule, which had been the iron law of the planet for nearly 1 million years, encounters a variable it has never seen before. A variable that is not made of rock or ice or gas, but of intelligence, of agency. We are approaching the Holocene, the new whole, the current warm epoch that has cradled all of written history. By all rights, by all the precedents of the past 8 cycles, this period should have ended thousands of years ago. The ice should have returned. The glaciers should be grinding over Canada right now. The carbon should be dropping. The curtain should be falling. But the curtain remains up. The stage is still lit. The winter is late. And in this delay, in this broken rhythm, lies the greatest mystery of all. Is the rule merely paused, or is it broken forever? We stand at the peak of the mountain of time, looking down at the long, jagged road we have traveled, the sawtooth ridges of the past rising behind us in the mist. The pattern is perfect. The repetition is hypnotic. It lulls us into believing that the future must resemble the past. But as we turn to face the horizon of the now, we see that the road ahead does not curve back down into the valley of the ice as it should. It stretches out, flat and strange, into a territory for which we have no map. The peak of the rule was the height of the ice's power, but every peak is followed by a descent, or in this case, a departure. The rhythm that sustained the world for eons is about to miss a beat, and in the silence of that missed beat, a new kind of world will have the chance to grow, a world that will build cities, write symphonies, and eventually look back at the ice and wonder where it went. The fever broke. The long, delirious dream of the ice ended, not with a whimper, but with the rush of water we spoke of before, the great draining of the continents that washed away the mammoths in the silence. And then, something miraculous happened. The pendulum of the climate, which had been swinging wild and wide for millions of years, violently thrashing between the deep freeze and the brief spikes of heat, suddenly slowed. It found a center. It settled into a hum, a steady, gentle vibration that was neither too hot nor too cold, but perfect. We call this time the Holocene. It is a name that means entirely recent, but in the emotional language of our species, it means home. It is the last 11,700 years of Earth's history, and it is the single most important anomaly in the geological record. To a geologist looking at the charts of the deep past, the Holocene stands out not for its drama, but for its lack of it. It is a flat line. After the jagged, saw-toothed chaos of the Pleistocene, where the temperature graph looks like the frantic scribbling of a seismograph during an earthquake, the Holocene looks like the calm surface of a lake at dawn. The temperature stabilized. The sea levels, after rushing up 400 feet, stopped rising and held their position, lapping gently against the new coastlines of the world. The seasons became predictable, reliable, almost clockwork in their regularity. This stability is the only reason we are here, discussing this story in a language of written words. Before the Holocene, the world was too volatile for civilization. You could not plant a field of wheat if you did not know whether the summer would bring rain or a blizzard. You could not build a city of stone near the coast if the ocean might rise 10 feet in a generation. The human species existed, clever and capable, but we were nomads, surfers on the chaotic waves of the climate, moving, adapting, reacting. We were passengers. But when the Holocene settled in, when the great volatility ceased, we put down roots. We planted the first seeds in the Fertile Crescent, not because we suddenly got smarter, but because the sky finally allowed it. We built Jericho, Memphis, Rome. We built the Great Wall and the pyramids, cathedrals, and skyscrapers, all on the assumption that the ground would stay dry and the harvest would come. We are the children of this long summer. We have grown up believing that stability is the norm, that the earth is a benevolent garden designed for our comfort. But the old rule, the deep 100,000-year rhythm that governed the ancestors, has not vanished. It is merely waiting. And if we look at the clock of the stars, the Holocene is beginning to look strange. It is lasting too long. According to the strict schedule of the ice ages, the party should be over by now. The interglacials of the past, the Eemian, the Holsteinian, were short, sharp affairs, lasting perhaps 10,000 years before the curve turned downward again. We are now nearly 12,000 years into ours. The sell-by date of the warmth has passed. We are living on overtime. If you look at the orbital mechanics, the alignment of the Earth and Sun today is eerily similar to the alignment that triggered the last major ice age. The summer sunlight in the northern hemisphere is weak. The tilt is decreasing. The wobble has moved us away from the optimal heat. By every law of the 800,000-year rule, the glaciers should be growing. The forests of Canada and Siberia should be dying back, replaced by the gray silence of the tundra. The snow should be lingering in the Scottish Highlands and the mountains of Norway, refusing to melt in August. We should be well on our way into the next descent, sliding down the slope toward the cold. But we are not. The glaciers are retreating, not growing. The tundra is thawing, not expanding. The temperature is rising, not falling. The Earth has stopped listening to the orbit. It is a moment of profound disconnection, a decoupling of the planet from the stars. It is as if the puppet strings have been cut and the dancer is moving of its own accord. Some scientists call this the Holocene exception. It poses a question that is both scientific and philosophical. Is this stability natural? Did the Earth somehow find a new equilibrium, a sweet spot that allows it to resist the pull of the cold, or is something else interfering with the gears? For a long time, we thought the Holocene was just a lucky break, a particularly long roll of the dice. We thought the orbit was just slightly different enough, perhaps a double bump in the eccentricity cycle that gave us a reprieve. But the math doesn't quite support that. The forcing for cooling, the astronomical push toward the ice, is strong right now. It is nearly as strong as it was when the ice sheets began to grow 115,000 years ago. The Earth should be cooling. And in fact, for a brief moment, it tried to. About 5,000 years ago, during the mid-Holocene, there was a dip, the neo-glacial. The glaciers in the Alps advanced slightly. The Sahara began to dry out. The world cooled a fraction of a degree. It looked like the beginning of the end, the start of the slide. But then, it stopped. The cooling stalled. The curve flattened out again. The ice withdrew. It was a false start, a hesitation. The rule tried to assert itself, tried to pull the world back into the rhythm of the ages, but something pushed back. Something held the door open. We look at this flat line of the Holocene temperature graph and we see safety, but a climatologist sees tension. A flat line in a dynamic system usually means two opposing forces are pushing against each other with equal strength. The sun says, cool, and some other force says, warm, and the result is a stalemate, a standoff. We are living in the eye of a hurricane that has been frozen in time. The stability we cherish, the predictable rains and the steady seas, may not be a peaceful resting state, but a suspended collapse. It is the silence of a dam holding back a river, and the longer it holds, the more unnatural it feels. The 100,000-year cycle was a rule of constant motion, of change, of flux. To stay the same, to stay warm, to stay stable for 12 millennia is, in the context of the Pleistocene, an act of rebellion. It breaks the pattern. And like all rebellions, it invites the question, how long can it last? How long can the Earth resist the gravity of its own history? We walk through our cities, drive our cars, tend our gardens, blissfully unaware that we are inhabiting a geological anomaly. We assume the Holocene is the way the world is supposed to be, but the ghosts of the glaciers are watching from the poles, waiting for the anomaly to correct itself. The ice sheets of Greenland and Antarctica are the last remnants of the empire, the rear guard of the cold that has not yet surrendered. They are the reminders that the Holocene is not a permanent victory, but a ceasefire. And as we look closer at why the ceasefire has held, why the cooling that started 5,000 years ago suddenly stopped, we begin to find clues that are unsettlingly familiar. We find that the force pushing back against the ice might not be a geological accident at all. It might be something far smaller, far newer, and far more intimate. It might be the result of a new kind of creature that learned to clear the forest and turn the soil. The Holocene exception may not be a gift from the universe. It may be a creation. And if that is true, then the rule wasn't just broken. It was dismantled, piece by piece, by the very hands that built the civilization the warmth made possible. We stand now in the ghost of a future that never arrived, a shadow world of what should have been. If we were to follow the strict, uncompromising logic of the last 800,000 years, if we were to let the rhythm of the orbit play out without interruption, the world outside your window would look very different. Let us imagine, for a moment, this phantom timeline, this missing verse in the song of the Earth. In this alternate present, the northern latitudes, the places we know as Canada, Scandinavia, Scotland, and Russia, would be places of silence and gathering white. The summer sun, weak and distant due to the current orbital alignment, would fail to melt the winter snows. Year after year, the drifts in the high valleys of the Laurentians and the Urals would deepen, turning from soft powder to hard blue fern, and then to ice. The tree line, that ragged border between the living forest and the barren tundra, would be marching south, a slow-moving wave of gray dying. The great boreal forests, the lungs of the north, would be suffocating under the cold, their spruce and fir trees snapping under the weight of the snow or withering in the dry, biting wind. The peatlands, those vast sponges of carbon, would freeze solid, locking their gases away in the permafrost. There would be no cities in these places, no lights visible from space, only the wind, whistling over the nascent glaciers that were beginning to coalesce, linking arms across the valleys to form the next great ice sheet. This is the missing ice. It is a physical absence that is almost as heavy as the presence of the ice itself. We are living in a gap, a pause, a vacuum where the cold should be. Scientists have calculated the inception threshold, the precise amount of summer sunlight below which an ice age is triggered. It is a line in the sand drawn by physics, and the terrifying, beautiful truth is that we have crossed it. We crossed it thousands of years ago. The sunlight hitting the high northern latitudes today is low enough. The trigger was pulled. The signal was sent from the sky to the earth, a command whispered by the precession of the equinoxes. Freeze. But the earth did not obey. The glaciers did not form. The ice sheets remained trapped in their mountain strongholds, unable to break out and reclaim the plains. It is as if a scheduled train never arrived at the station, leaving the platform empty and silent. We look at the geological clock, and it reads winter, but we look at the thermometer and it reads summer. This discrepancy is the missing ice. It represents thousands of cubic miles of frozen water that simply failed to materialize. And because this ice is missing, the other dominoes of the apocalypse failed to fall. Because there was no growing white mirror to reflect the sun, the albedo feedback loop did not kick in. The earth kept absorbing heat. Because the oceans did not cool down drastically, they did not suck the carbon dioxide out of the atmosphere with the ravenous hunger of the past. The greenhouse effect stayed strong. The system stalled. It is an eerie feeling to realize that our entire civilization, the farms that feed us, the ports that connect us, the very climate that allows us to exist in these numbers, is built on a skipped beat. We are squatters in a time that belongs to the ice. We are dancing in a ballroom that was booked for a funeral. And the question that haunts the edges of this realization is, why? Why did the Earth ignore the signal this time? Was the signal too weak? Did the chaotic nature of the atmosphere simply throw a random wobble that canceled it out? Or was there something else, a new variable, a subtle finger on the scale that held the temperature just above the danger zone? We look back at the climate record of the last few thousand years, searching for the anomaly. We see the natural cooling trend that began after the peak of the Holocene warmth, the slow drift downward that looked like the start of the end. But then, mysteriously, the drift leveled off. The carbon dioxide levels, which should have been dropping in lockstep with the cooling, did something unprecedented. They stopped falling. And then, slowly, strangely, they began to rise. This happened long before the steam engine, long before the coal factories of the Industrial Revolution. It happened in the quiet, pre-industrial past, a time of stone tools and bronze swords. This pre-industrial rise is the smoking gun of the missing ice. It suggests that something was keeping the blanket on the world, preventing the heat from escaping, keeping the temperature just warm enough to frustrate the glaciers. It was not a massive surge of heat, just a gentle, sustained warmth, a few degrees of difference, but in the delicate threshold-based system of the climate, a few degrees is everything. It is the difference between rain and snow. It is the difference between a river that flows and a river that freezes. It is the difference between a farm and a glacier. The missing ice is a ghost story. It tells of a monster that was summoned but could not cross the threshold. It tells of a natural cycle that ran for nearly 1 million years, unbroken until it met a force it could not overcome. And so, the ice waits. It waits in Greenland, a remnant of the old empire, watching the south with cold, melting eyes. It waits in Antarctica, holding its breath. But the great invasion, the return of the mile-high walls of white to North America and Europe, has been canceled, or at least indefinitely postponed. We walk on land that should be buried. We breathe air that should be thin and cold. We live in a stolen summer, a season that has been extended by mysterious means, allowing us to build our world in the space between the snowflakes. The absence of the ice is the presence of us, but an absence cannot last forever. A vacuum demands to be filled. The tension between what the orbit wants and what the atmosphere is doing creates a strain in the system, a potential energy that must eventually be resolved. But for now, the mountains are bare, the valleys are green. The rule has been broken, not by a shout, but by a silence, the silence of the ice that never came. We look for the cause of this broken rule, this stolen summer, and we expect to find a geological titan, a shift in the deep earth, a wobble in the sun, a change in the ocean currents. But the answer may lie in something far smaller, far more fragile, and entirely unexpected. We must turn our gaze from the high, cold atmosphere to the muddy banks of a river in the Yangtze Valley, or the dense green forests of Neolithic Europe. We must look at a creature that stands on 2 legs, holding a stone axe looking at a tree. This is the moment of the human intervention. It is a controversial idea, a whisper in the scientific community that has grown into a shout. The hypothesis that we did not just stumble into the Holocene warmth, but that we unknowingly helped to maintain it. It suggests that the Anthropocene, the age of humans, did not begin with the steam engine or the atomic bomb, but with the first seed planted in the wet earth. To understand this, we must go back roughly 8,000 years. The natural cycle of the Earth, driven by the orbit, dictated that carbon dioxide levels should have been dropping. The planet should have been cooling, preparing the ground for the return of the ice, and for a while, it did. But then, the line on the graph turned. CO2 began to rise. Why? Look at the forests. At this time, humans were spreading across Europe and Asia, and they were bringing with them a new technology: agriculture. To plant crops, you must clear the land. For thousands of years, the sound of the axe and the smell of smoke defined the frontier of human expansion. Millions of acres of dense carbon-storing forest were cut down and burned to make way for wheat and barley. When trees burn, or when they rot, they release their stored carbon back into the sky. It was a slow release, a trickle compared to the smokestacks of today, but it was persistent. Year after year, century after century, the forests receded and the carbon rose. But there was a second, perhaps even more potent change. About 5,000 years ago, in the warm, wet lowlands of Asia, farmers began to flood their fields to grow rice. A flooded field is a swamp, and a swamp is a methane factory. In the oxygen-poor mud at the bottom of the paddy, bacteria feast on rotting plant matter and burp out methane, a greenhouse gas 20 times more powerful than carbon dioxide. As wet rice farming spread across China and Southeast Asia, a new plume of warming gas began to rise into the atmosphere. Again, by modern standards, these emissions were tiny. They were a drop in the bucket. But we must remember the lesson of the weak signal. The climate system is not about brute force. It is about timing. These ancient farmers were adding greenhouse gases to the atmosphere at the exact moment the Earth was balancing on the edge of the cooling trend. They were pushing on the swing just as it tried to swing back. The extra carbon and methane provided just enough warmth to counteract the orbital cooling. It was a perfect accidental cancellation. The sun whispered, "cool," and the rice paddies whispered, "warm," and the result was the flat, stable line of the Holocene. It is a dizzying thought that the reason the ice sheets did not return to cover Canada might be because of the collective labor of millions of anonymous ancient farmers working in the mud, unaware that their daily toil was altering the thermal destiny of the planet. They were not trying to change the climate, they were just trying to feed their children. Yet, their handprint is there, in the air bubbles trapped in the ice of Antarctica. We see the methane spike, we see the CO2 deviation, we see the moment the rule began to bend. This idea changes the way we see ourselves in the deep story of the Earth. We are not just passengers on the bus, we have been reaching for the steering wheel for much longer than we thought. We have been geoengineers for millennia, operating in a state of innocent ignorance. We held back the ice with a plow. We kept the winter at bay with a fire. It suggests that civilization and the climate are not separate things, but deeply intertwined. The stability that allowed us to build cities was, in part, a stability we manufactured ourselves. We created the garden we live in. But this intervention was a double-edged sword. It saved us from the ice, yes. It gave us the long summer of history. But it also started a process that has no brakes. We didn't know we were warming the world. We just knew that clearing the forest made the soil rich. We didn't know that methane trapped heat. We just knew that wet rice grew better than dry rice. We were pulling levers we didn't understand, tinkering with the thermostat of a machine we hadn't bothered to read the manual for. And for thousands of years, this accidental balance held. The human warming perfectly offset the natural cooling. It was a Goldilocks era, not too hot, not too cold. But balance is a fragile thing. It relies on the forces remaining equal. And as we moved from stone tools to iron, from iron to coal, from coal to oil, we ceased to be a subtle force. We ceased to be a weak signal. We became a geological superpower. The axe became the chainsaw. The campfire became the blast furnace. The gentle nudge became a violent shove. The intervention that began as a quiet, inadvertent delay of the ice has morphed into something entirely different. We have gone from canceling out the cooling to overpowering it completely. We have moved from holding the swing steady to pushing it wildly in the other direction. The ancient farmers stopped the ice age, but they also opened the door to a heat age that the Earth hasn't seen in millions of years. We stand now in the legacy of those first unintentional decisions. We are the heirs of the rice paddy and the burning forest. We are the children of the intervention. And as we look at the rising temperatures of today, we realize that we are no longer waiting for the ice. The ice is gone. The danger is no longer the cold silence of the 100,000-year winter. The danger is the heat that comes when you break the rule too hard. The ancient rhythm is dead, killed by the slow accumulation of human breath and human fire. We have stepped out of the cycle. We have left the track. And the question now is not when the ice will return, but where this new, uncharted road leads. We have taken the reins of the planet, whether we wanted to or not. The pilot is no longer the orbit. The pilot is us. And we are flying blind into a future that has no analog in the ice cores, no precedent in the rocks, a future that is entirely, terrifyingly of our own making. And then the whisper became a roar. The slow, accidental intervention of the first farmers, the gentle nudge of the rice paddy in the clearing, was replaced by a force of geological violence that the earth had not seen since the great volcanic eruptions of the deep past. We entered the age of the carbon shield. It began quietly enough, with the digging of black stones from the damp earth of England and the pumping of dark viscous liquid from the sands of Pennsylvania. But these were not just stones and fluids. They were batteries. They were vaults of ancient time. Inside, every lump of coal and every barrel of oil lay the ghost of a prehistoric summer, the concentrated energy of sunlight that had fallen on the earth millions of years ago, absorbed by giant ferns and plankton, and then buried, crushed, and forgotten. For eons, this carbon slept in the dark, removed from the cycle of the air. The atmosphere had balanced itself without them, settling into the cool, crisp rhythm of the ice ages. But when we burned them, when we struck the match and lit the furnace, we did not just create heat. We released time. We opened the vaults and unleashed millions of years of stored sunlight all at once. In the blink of a geological eye, a mere 2 centuries, a duration so short it would not even register as a distinct line on the chart of the last million years, we returned this ancient carbon to the sky. The result was the construction of a shield. Invisible, odorless, and silent, the concentration of carbon dioxide in the atmosphere shot upward. For 800,000 years, through all the wild swings of the ice and the melt, the level had never risen above 300 parts per million. It was a hard ceiling, a limit set by the ocean and the biosphere. But today we have punched through that ceiling and left it far behind. We are climbing toward levels not seen since the Pliocene, millions of years ago, before the ice ages even began. This is the carbon shield, a thickening blanket that wraps the planet, allowing the sun's light to enter but refusing to let the Earth's heat escape. It is the ultimate breaker of the rule. The subtle orbital cycles that drove the 100,000-year rhythm are still there. The Earth still stretches its orbit, still nods its axis, but their signal has been drowned out. The faint cooling influence of the Milankovitch cycles is now overwhelmed by the warming force of the shield. It is like trying to hear a whisper in the middle of a thunderstorm. The sheer volume of greenhouse gases has effectively decoupled the climate from the cosmos. The ice age that was due, the descent that should have arguably begun a few thousand years ago, or perhaps in another 1,000, has been canceled. Not just delayed, but erased. Scientists who model the future of the ice sheets tell us that even if we stopped all emissions tomorrow, the shield we have already built is strong enough to suppress the next glaciation for 50,000 years, perhaps 100,000. We have created a super-interglacial, a period of warmth so long and so deep that it may break the cycle of the ice forever. The rhythm of the quaternary is dead. The metronome has stopped. We are no longer living in a world governed by the delicate interplay of snow and sun. We are living in a world governed by the chemistry of the atmosphere we have engineered. There is a profound strangeness in this. We tend to think of nature as something big and powerful that happens to us and ourselves as small things that struggle to survive it. But the carbon shield flips the script. We have become the atmosphere. The air we breathe is no longer a wild thing. It is a human artifact, its composition determined by the choices of our economies and our industries. We have wrapped the earth in a coat of our own making, a coat that is too warm, a coat that we cannot easily take off. The ice sheets of the north, those ancient enemies that crushed the continents, are now the victims. They are retreating not because the orbit has shifted, but because the air touching them is carrying the heat of 1 billion fires. The permafrost, the frozen ground that has held the North together for millennia, is softening, releasing its own ancient ghosts into the sky. The feedback loops that once amplified the cold, the white mirror, the carbon-starved ocean, are now running in reverse, amplifying the heat. The mirror is shattering, the dark ocean is absorbing, the shield is thickening. And yet, amidst this transformation, there is a strange quiet. The sky does not look different. The sun does not look different. The change is invisible, felt only in the statistics of the thermometer and the retreating edges of the glaciers. It is a silent revolution. The Earth has followed the Ice Age rule for 800,000 years, then broke it, and the breaker of the rule was not a star or a volcano or an asteroid. It was a fire that started in a cave, moved to a hearth, grew to a furnace, and finally became a global engine that consumed the very sky itself. We drift now under this new, heavy blanket, looking down at a world that is feverish, a world that has forgotten how to cool down. The ancient pulse is gone. The long winter is over, and we are left alone in the greenhouse, watching the mercury rise, wondering if we have broken the machine beyond repair, or if the Earth, in its infinite slow wisdom, has one more trick left to play. The shield is up. The ice is down. And the story of the climate has entered a chapter that has never been written before. We have reached the end of the timeline, drifting from the deep frozen silence of the ancient past to the warm, uncertain quiet of the now. We stand on the shore of a new ocean, listening for a sound that has stopped. For nearly 1,000,000 years, the Earth hummed a specific song, a low rhythmic chant of ice and fire, a heartbeat that pulsed once every 100,000 years. It was the rhythm of our origin, the beat to which our species learned to walk, to hunt, to think. It was a rule that seemed as solid as the bedrock, a promise that the winter would always return and the summer would always end. But the heartbeat has faded. The metronome has stilled. The great pendulum of the climate, which swung with such terrifying regularity between the white empire and the green reprieve, has been caught in mid-air, held by the invisible hand of the carbon shield. We are living in the silence of the rhythm. It is not an empty silence, but a pregnant one, filled with the hum of a new reality that is struggling to be born. The old cycle, the 100,000-year loop of the eccentricity and the feedbacks, is broken. It is a machine that has been switched off. The gears of the orbit still turn, the stars still shift, but they no longer connect to the levers of the Earth. The planet has moved on. It has entered a state that has no name in the old language of the Quaternary. Some call it the Anthropocene, but in the quiet of the night, names matter less than the feeling of the change. It feels like waking up from a long, repetitive dream. In the dream, we were trapped in a maze of ice, running the same circles over and over, building and destroying, freezing and thawing. Now we are awake, and the maze is gone, replaced by an open field. It is a scary place, perhaps, because there are no maps here. We cannot look at the ice cores to tell us what will happen next, because the ice cores only remember the old rule. They do not know this new world. We are the cartographers of the unknown. And yet, there is a strange peace in this breaking. It reminds us that nothing in the universe is truly permanent. The rule of the Ice Age felt eternal to the mammoth and the cave bear, just as the rule of the dinosaurs felt eternal to the fern forests of the Cretaceous. But rules are just habits. They are patterns that hold for a while, until the energy shifts, until the system evolves, until a new force emerges to rewrite the script. The Earth is not a static stage. It is a story that is still being written. We are not just reading the history, we are the ink. The breaking of the Ice Age cycle is not an end, but a transformation. It is the Earth shedding a skin that no longer fits. The glaciers may be retreating, the seas may be rising, but the planet itself remains, resilient, adaptable, vast. It has survived fire and ice, impact and eruption, and it will survive us. The silence of the rhythm is not the silence of death. It is the silence of a pause, a breath taken before the next movement begins. We can stop looking over our shoulder for the return of the white wall. It is not coming. The long winter is over. We have broken the lock. And as we drift away from the science, away from the data, away from the anxiety of the future, we are left with only the simple physical reality of the moment. The earth is warm. The air is still. The stars are watching, indifferent and bright, shining down on a planet that has decided to change its mind. We are small, fragile things living on the surface of a miracle, a rock that floats in the void, a rock that has forgotten how to freeze. And in that forgetting, there is room for something new to grow. The story of the ice is finished. The story of what comes next is just beginning. But that is a story for another night, for another dreamer. For now, the only rule that matters is the rule of rest. The history of the world is a heavy thing to carry, and you have carried it far enough. It is time to lay it down. It is time to let the millions of years slide off your shoulders like a heavy coat, leaving you light, leaving you safe, leaving you here in the warmth of the present, where the only rhythm is the slow, steady beating of your own heart, echoing the quiet pulse of a world at peace. The great wheel has stopped turning. The glaciers have receded into the mist, and the roar of the changing earth has softened to a whisper, and then to silence. We are no longer travelers across the deep time. We are simply here, in this room, in this moment. The past is a dream that is fading, its edges blurring into the dark. The worry of the future is a cloud that is blown away. There is only the stillness. The air around you is calm. The shadows are gentle. You are part of the earth, and like the earth, you have found your balance, your quiet center. The cycle is complete. The night is a blanket, softer and warmer than the ice ever was, wrapping you in safety. Let the darkness hold you. Let the silence fill you. You are safe. You are warm. You are home. Sweet dreams.